Hello everyone, I'm going to discuss the topic components of a force. No? So if force F is to be resolved into components along the x and the y-axis, so we need to construct a parallelogram by drawing the lines starting from the tip of the force F, and one line is parallel to the x-axis, no? And the other line is parallel to the y-axis. So these lines intersect with the x and y-axis, forming a parallelogram. No? So the line joining the tail of F and the intersection point on the x-axis, no, is called the x component, no? Or we have the f sub x. And the line joining the tail of F and the intersection point on the y-axis is the y component, or we have the f sub y. No? So when a force is resolved into two components along x and y axis, the components are then called rectangular components. The rectangular components of force F shown are found using the parallelogram law. So that the vector sum F is equal to F sub x plus F sub y. No? So the components of the force F form a right triangle. No? So by triangle rule, we have the head of the x component, is connected to the tail of the y component. Then the triangle is formed by connecting the tail of the x component to the tail of the force F and the head of the y component to the head of the force F. No? So we have a right triangle. So to compute for the magnitude of the components, so we're going to use cosine theta is equal to adjacent over hypotenuse, and sine theta is equal to opposite over hypotenuse. No? So for cosine theta, so equal to adjacent over hypotenuse. No? So from the given right triangle, the adjacent side is the x component. No? So to solve for the magnitude of the x component, so we have cosine theta is equal to the adjacent side, so that is the f sub x over hypotenuse, which is the force F. So cross multiply, so we have x component is equal to the force F times the cosine theta. No? So we have formula now to solve for the x component, based on this right triangle. Then next, so we have the sine theta equal to opposite over hypotenuse. So the y component is the opposite side of the angle theta. So we have sine theta is equal to opposite, so f sub y over hypotenuse, which is the force F. So cross multiply. So y component is equal to F times sine theta. So we have the formulas to compute for the x and y components. So we have a force at the quadrant 1, so the same as the previous figure, but this time the force makes an angle with respect to the y-axis. So this is your angle theta. So with respect to the y-axis. So from this figure, so the right triangle is, so we have the y component, the x component, and the force F. And this is your angle theta. So based from this figure, so we have cosine theta equal to adjacent over hypotenuse, and sine theta is equal to opposite over hypotenuse. So The adjacent side of the angle theta is the y component. So we have cosine theta is equal to y component over hypotenuse f. So cross multiply. So y component is equal to f times cosine theta. No? So this formula, no? So we solve the y component using the cosine theta. No? Then next, sine theta is equal to opposite over hypotenuse. The opposite side of the angle theta is the x component. So we have sine theta is equal to x component over f. So cross multiply. So x component is equal to f times sine theta. No? So the x component is solved using the sine theta. Instead of using angle theta, the direction of f can also be defined using a small slope triangle. No? So in this figure, the small slope triangle is the right triangle with sides A, B, and C. So the triangle formed by the components of force F and the small slopes triangle are similar triangles. No? So x component corresponds to side A, the y component corresponds to side B, and the force F corresponds to side C. No? So the proportional length of the sides gives us, no? So x component over F is equal to A over C. So from this proportion, we can solve the magnitude of x component. So cross multiply. So x component is equal to F times A over C. So we have the formula for the x component. The next, y component over force F so equal to, so y component corresponds to B, so B over C. So solving for the magnitude of y component, so cross multiply. So we have y component is equal to F times B over C. Then we have the signs of components. No? So if we have the force F at the quadrant 1, so the x component, f sub x, and the y component, so x component is positive, so y component is positive, so also positive. For quadrant 2, if the force is at the quadrant 2, so the x component is to the left and the y component is upward. So x component is negative, y component is positive. Okay. For the third quadrant, so the x component is to the left and the y component is downward. So the x component is negative, y component is also negative. And the fourth quadrant, so the x component is to the right and the y component is downwards. The x component is positive and the y component is negative. So we have example number 1. Resolve each force acting to the object into its x and y components. So we have F1, 300 newtons, F2, 450 newtons, and F3, 600 newtons. So first, we're going to solve the x and y components of the force 1. no? So that is 300 Newton, no? So 1x, no? So since the force 1 is along the positive y-axis, so the x component is 0. And next, the y component, no, is 300 Newton. No? So positive because the force 1 is upward direction. So next is F2. Now F2 is 450 newtons, no? 45 degrees above negative x axis, no? So the x component is to the left and the y component is upward, no? So it is at the quadrant 2, so the x component is negative and the y component is positive, no? So to solve the x and y components, so we're going to create a triangle force, no? So x component, no? Or let's call it as F2x, or the x component of force 2. Then the y component, let's call it as F2y, and the force F or F2. And this is your angle theta, which is 45 degrees. So first, let's solve the magnitude of the x component. No? So x component is the adjacent side of the angle 45 degrees. So we're going to use, so cosine theta is equal to adjacent over hypotenuse. No? So cosine theta is equal to adjacent side. So f2x over hypotenuse. So f2. So cross multiply. So f2x is equal to f2 times cosine theta. Then substitute f2. So that is 450 newtons. So times cosine 45 degrees. So 450 times cosine 45. We have 450 times cosine 45 so equal to 318.198 newtons. So since the x component is along negative x-axis to the left, so the sign is negative. No? So negative 318.198 newtons. Next, so we're going to solve for the y component, no, or F2y. So it is the opposite side of the angle, 45 degrees. So we're going to use sine theta equal to opposite over hypotenuse. No? So sine theta is equal to F2y over F, cross multiply. So F2y is equal to F times sine theta. No? So F is 450 newtons times sine 45 degrees. So 450 times sine 45. So that is 318.198 newtons. No? So it is uh, upward. No? So it is positive. So 318.198 newtons. So that is the magnitude of y components. No. Next, no, we're going to solve for the x and y components of F3. No? So F3 is 600 newtons at quadrant 1. No? So at quadrant 1, so we have this x component, so we call it F3x, and y component, so F3y. No? So instead of angle theta, so the direction is defined by the small slope triangle, so with sides 3, 4, and 5. No? So gawin natin. No? So we have the triangle formed by the components, so F3x and F3y, and the force F3, and the small slope triangle, so 3, 4, 5. So they are similar triangles. So we have, no, so F3x over F3, so equal to, so F3x corresponds to side 3, so that is 3 over, then F3 corresponds to side with length of 5, so we have over 5. So solving for the component x, so F3x is equal to F3 times 3 over 5. Then substitute F3, so that is 600 newtons times 3 over 5, so equal to, so 600 times 3 over 5, so that is 360 newtons, no? So positive. Then solving for F3y, so F3y over F is equal to, so F3y corresponds to 4, no, over F3, then F3 corresponds to 5, so over 5, so cross multiply, so F3y so equal to F3 times 4 over 5, so F3 600 newtons times 4 over 5, so F3y is equal to, so 600 times 4 over 5, that is 480 newtons, no? So that is the y components, 480, and the x component is 360 newtons. Example number 2, resolve each force acting to the object into its x and y components. So we have three forces, so F1 200 newton, F2 260 newton, and F3 100 newton. So first, we're going to solve the x and y components of F1. So F1 is in the quadrant 2, so the x component is to the left, so let's call it as F1x, and the y component is upward, so let's call it as F1y. No? So we're going to make a triangle force, so using the x and y components. No? So we have the F1y, then F1x, and the 200 Newton. So 200 Newton makes an angle of 30 degrees, so with respect to the y-axis, or the F1 is 30 degrees to the left of y-axis. No? So we have force F, no, or F1, and then the 30 degrees. No? So solve for x component. No? So as we can see in our force triangle, no? So x component is the opposite side of the angle 30 degrees. So we're going to use, so sine theta is equal to opposite over hypotenuse. No? So sine theta, so the opposite side is the f1x over hypotenuse f1. So cross multiply, so f1x is equal to f1 times sine theta. So f1 is 200 newtons times sine 30 degrees. So f1x is equal to, so let's compute it. So we have 200 times sine 30, so that is 100 newtons. No? So F1x is 100 newtons. So F1x is to the left. No? So F1x is negative 100 newtons. So that is our F1x. So next, solve for F1y, or the y component. So y component is the adjacent side of the angle 30 degrees. So we're going to use, so cosine theta is equal to adjacent over hypotenuse. No? So cosine theta is equal to adjacent side, so f1y over f1. So f1y is equal to f1 times cosine theta. So f1 is 200 newton times cosine 30 degrees. So f1y is equal to, so 200 times cosine 30, so 173.205. No? So upward, so positive, so 173.205 newton. So that is our F1y. No? So F1x, negative 100 newton, and F1y is positive 173.205 newton. No? What if hindi natin gagamitin si 30 degrees? So, gamitin natin, so yung angle with respect to the x-axis. No? So, or gagamitin natin itong angle theta x. So, ano yung value ng angle theta x na yan? No? So, angle 30 plus angle theta x is equal to 90 degrees, no? So, yung isang quadrant. So, solving for theta x, so we have theta x plus 30 degrees, so equal to 90 degrees. So, theta x is equal to 90 degrees minus 30 degrees. So, theta x is equal to 60 degrees. So, check natin kung parehas ba yung makukuha nating sagot, no? So, yun po, no? So, we're going to use the angle 60 degrees, no? So, with respect to the x-axis, no? So, triangle force natin. So, we have the F1x, then F1y, and the force 1, no? So F1, and this is your angle 60 degrees. No? So for this time, no, in our fourth triangle, so F1x becomes the adjacent side of the angle 60 degrees. So we're going to use cosine theta. No? So cosine theta is equal to adjacent over hypotenuse. So F1x over F1. No? So F1x equal to F1 times cosine theta. So F1 is 200 Newton times cosine theta. So F1x is equal to, so 200 Newton times cosine 60 degrees. So that is equal to 200 times cosine 60. So that is equal to 100. No? So x component is to the left. So F1x is negative 100 Newton. So same lang din yung nakuha natin sa unang solution. No? So next, no? So F1y, so that is the opposite side of the angle. So sine theta is equal to F1y, no, over F1. So F1y is equal to F1 times sine theta. No? So we have 200 newtons times sine 60 degrees. So F1y is equal to, no? So 200 times sine 60 degrees. So 173.205. No? So F1y is 173.205 Newton. So parehas lang din. So F1y. No? So we have two solutions, no, to solve for the x component and y component of force 1. No? So the first one, so we use the given angle 30 degrees with respect to the y-axis. No? And yung second solution natin ay we use, no, 60 degrees, no? So with respect to the x-axis. No? So next, we're going to solve the x and y components of force 2. No? So that is F2, which is 260 Newton at quadrant 4. No? So there is a small slope triangle, so with sides 5, 12, and 30. No? So the x component of F2, so is along positive x-axis. So let's call it as F2x, and the y component is along negative y-axis. So let's call it as F2y. No? So the fourth triangle, no? So that is F2y, and we have the F2x. Then we have the force F. No? So let's call it F2. Then we have the small slope triangle. So that is 5, 12, 13. So they are similar triangles. No? So solving for the x component, so we have F2 x over F2 is equal to, so F2x corresponds to 12. So 12 over F2, so corresponds to 30. So cross multiply. So F2x is equal to F2 times 12 over 30. Then F2, so that is 260 Newton times 12 over 30. So F2x is equal to, so 260 times 12 over 30. So 240 newtons. No? So 240 newtons. So positive. No? So the force is to the right. The next, solving for F2y component. No? So F2y over F2, so equal to, so F2y corresponds to 5 and F2 corresponds to 30. So 5 over 30. So cross multiply. So F2y is equal to F2 times 5 over 30. No? So F2, 260 Newton times 5 over 30. So F2y is equal to, so 260 times 5 over 13. So that is equal to 100 newtons. No? So 100 newtons. So F2y is downward. So that is negative. Negative 100 newton. So the x and y components of force 2 is 240 newtons and negative 100 newtons respectively. And last, so we're going to solve for the x and y components of force 3. No? So force 3 is at the quadrant 3. So the x component is to the left. No? So let's call it F3x. And the y component is downward. So let's call it as F3y. No? So the triangle force by the x and y components. So we have F3x, then F3y, and the force F3. And that is 30 degrees below negative x-axis. No? So next, so solve for the x component. So F3x is the adjacent side of the angle 30 degrees. So we're going to use cosine theta is equal to adjacent over hypotenuse. No? Cosine theta is equal to F3x over F3. So cross multiply. So F3x equal to F3 times cosine theta. So F3, so that is 100 newtons times cosine 30 degrees. So F3x is equal to, so 100 times cosine 30. So that is 86.602. No? So 86.602 Newton. So that is to the left. So we have negative 86.602 Newton. The next, solving for y component, F3y. So F3y is the uh, opposite side, no, of the angle 30. So we have sine theta is equal to opposite over hypotenuse. So sine theta is equal to F3y over F3. So F3y is equal to F3 times sine theta. No? So 100 Newton times sine 30 degrees. So F3y is equal to 100 times sine 30 degrees. And the answer is 50, no? Or that is negative 50 Newton. No? Yan.